Hello students, welcome to my channel Engineers Academy. Let's solve this particular problem. In this problem it is said that determine the force in each member of the truss and state if the members are in tension or compression, right? So these two problems are similar problems, but in the first case this theta is 0 and in the second case this theta is equal to 30 degrees, right? So I will solve the second problem. So if you understand the method of this second problem when theta is equal to 30 degrees, so you people will be able to solve this one as well, right? So here it is said that this roller is making some angle. The surface on which this roller exists is making some angle with the horizontal, right? So we are given that this roller, the surface of this roller is making some angle theta with the horizontal. The reaction at this roller will be perpendicular to this surface, right? So that reaction will be acting like this, right? And this reaction need to be perpendicular with this surface, right? So now if I draw a vertical line here, let me draw a vertical line here, right? So if I draw a horizontal line here, so this vertical line is perpendicular with this line, and this reaction, let's say that the reaction at this point C is denoted by R, right? So this R is making some angle with the vertical, right? So if this vertical line is perpendicular with this horizontal line and this reaction is perpendicular with this surface, right? So if here we have this angle, if this angle is theta, then this angle is also theta, right? So this means that this reaction R is making the same angle theta with the vertical, right? So here this angle is theta, right? So now we can write that that normal reaction is making angle theta here, right? So if this angle is 30 degree, then this reaction R is also making 30 degrees with the vertical, right? And similarly here we have pin support, so here we will have two reactions. Here we will have one reaction which will be acting in this direction, right? Let's say that this reaction is AX, and here we will have one another reaction which will be acting vertically upward, right? So let's say that this reaction is AY. So now we will start in this problem by finding the reaction force, that is AX, AY and R, right? So since we are given this 3 kN force at this joint D, but at this particular joint we have three unknown forces, right? That is the FAD, FBD and FDC. So we cannot start the solution from this particular joint D. Again, we cannot start from this joint B, since at this joint B we have again three unknowns and one known, right? So we need to start from that particular joint where we have at least one known force and two unknown forces, since we have two equations, the summation of forces along x equals to 0 and the summation of forces along y equals to 0. So we cannot start with this joint D, we cannot start from this joint B. So either we have to start from this joint A or either we have to start from this joint C. To start from joint A and C, we need to find this AX, AY and this reaction force, right? So if this R is making angle theta with the vertical, so again we can resolve this R into its component. So it will have one component will be acting in this direction like this. This will be the cos component. We can write that this component will be R cos of 30 degrees, and similarly this R will have one component will be acting in this direction like this, right? So this one will be R sine of 30 degrees. And in the first case when theta is equal to 0, so then the R will be acting only in the y direction, right? That is vertically upward. This is our positive x and y direction, right? So if theta is 0, so then this cos component will be R cos of theta, R cos of 0, and cos of 0 is 1. So we will have this only one reaction which will be acting vertically upward in the y direction, right? But in this particular case we have R cos of 30 degrees and R sine of 30 degrees. We have two components of this R, right? So now first what I will do is that I will consider this whole truss, right? And I will apply the summation of moment about point C, right? So we will apply the summation of moment about point C equals to 0, and we will assume that the counterclockwise moment is positive. So now as we can see that this AX is passing through that point C, so it will not produce the moment about that point C. right? And this AY is producing the clockwise moment about that point C. So I will write AY, and the perpendicular distance of this AY from that point C is 2 plus 2. So this we can write that AY into 4, right? And it is producing clockwise moment, so we will write minus with it. Similarly, this 3 kilonewton force is also producing the clockwise moment about that point C. So I will write minus 3, and the perpendicular distance of this 3 kilonewton force from that point C is this 1.5 meters. So I will multiply this with 1.5, right? Similarly, this 4 kilonewton force is producing the counterclockwise moment about this point C. So I will write plus 4, and the perpendicular distance of this 4 kilonewton force from that point C is this 2 meters. So I will multiply this with 2, and this is equal to 0. So when we solve this, so AY will be equal to 3 into 1.5 minus 4 into 2 divided by minus 4. So from this, AY equals to 0.875 kilonewton, right? So this is AY. Now if we apply the summation of moment about point A equals to 0, right? So if we apply the summation of moment about point A, so then as we can see, again we will assume that the counterclockwise moment is positive. So now as we can see that this sine component is passing through that point A, right? And this r cos of 30, this component is producing the counterclockwise moment about that point A. So I will write plus r cos of 30 degrees, and the perpendicular distance of this component from that point A is again 4. So I will multiply this with 4. Similarly, this 3 kilonewton force is producing the clockwise moment about that point A. So I will write minus 3, and the perpendicular distance of this 3 kilonewton force from that point A is 1.5. So I will multiply this with 1.5. Similarly, this 4 kilonewton force is producing the clockwise moment about that point A. So again I will write minus 4, and the perpendicular distance of this 4 kilonewton force from that point A is 2 meters. So I will multiply this with 2, and this is equal to 0. So from this we can write that r cos of 30 degrees, or we can say that 4 r cos of 30 degrees is equal to 3 into 1.5 plus 4 into 2, and if we divide both sides by 4 cos of 30 degrees, so we will get that r value. So when we solve this, so this r equals to 3.608 kilonewtons, right? So r equals to 3.608 kilonewtons. And similarly, if we apply the summation of forces along x to the whole truss, right? So now as we can see that this AX is acting in the positive x direction, so I will write AX. This 3 kilonewton force is acting in the positive direction, so I will write plus 3. And this sine component is acting in the negative x direction, so I will write minus. Now our magnitude is known, so this is 3.608 sine of 30 degrees, and this is equal to 0. So from this we can write that AX is equal to minus 3 plus 3.608 sine of 30 degrees, and when we solve this, so AX equals to minus 1.196 kilonewton. So now we know all these reaction forces. So this AY is 0.875 kilonewton, and from this we conclude that the assumed direction of AX is not accurate. It is acting away from this joint A, right? So we will write that the AX magnitude is, and let me redraw that AX reaction. So this is that AX reaction which is acting away, and this is its magnitude is 1.196 kilonewton, right? Now we will start with this joint C. So let's say that we want to analyze joint C for equilibrium, right? The whole truss is in equilibrium, so each particular joint is also in equilibrium, right? So now let's say that the force in this DC member is, or CD member is acting towards this joint C. Let's assume that it is compressive force, right? Let's say that it is acting towards this joint C, and let's assume that this FBC force is acting away from this joint C. Let's say that it is acting away from this joint C, right? So this is that FCD force and this is FBC force. So now we have this free body diagram. Let me isolate this. Now we have the components of R, right? So this is R sine of 30. So the R magnitude is 3.608. So 3.608 sine of 30 degrees is 1.804. I will write that this is 1.804 kilonewton, and R cos of 30 is 3.125 kilonewton, right? And since FCD is making some angle with the horizontal, so let's say that this angle is alpha. So we need to find this angle alpha, right? And this is the free body diagram of that joint C. So first we have to find this alpha angle. So to find this alpha, we have to apply tan alpha. So tan alpha to this BCD triangle. So according to this, tan alpha will be perpendicular. So perpendicular is 1.5 divided by the base, so which is 2. So from this, alpha is equal to tan inverse 1.5 divided by 2. So from this, alpha equals to 36.87 degrees. So this means that this FCD is making a 36.87 degree angle with the horizontal, right? So now if we apply the summation of forces along y equals to 0 at joint C, right? So this FCD will have two components. It will have one component which will be acting in this direction, and it will have one component which will be acting vertically downward. So this one is the cos component and this one is the sine component. So if we apply the summation of forces along y, so then as we can see that this component of FCD is acting in the negative direction and it is the sine component. So I will write minus FCD sine of alpha. Alpha is 36.87. right? And this 3.125 is also acting, this is acting in the positive y direction, so I will write plus, and this is 3.125, and this is equal to 0. So from this we can write that FCD will be equal to minus 3.125 divided by minus sine of 36.87. So from this we get FCD equals to 5.21 kilonewton, and as we know that this FCD is acting towards this joint C, so this means that this is the compressive force. As a reaction, this FCD will compress the CD member, right? So this is compressive force. Similarly, if we apply the summation of forces along x equals to 0 at joint C, so as we can see that the cos component of this FCD is acting in the positive x direction, so I will write that is FCD, and now FCD magnitude is known, so this is 5.21 cos of 36.87. This component is acting in the positive direction and this is acting in the negative x direction, so I will write minus 1.804, and this is also acting in the negative x direction, so this is FBC, so I will write minus FBC, and this is equal to 0. So if we bring this to the other side of equation, so this will become positive, right? So FBC is equal to this thing. So FBC equals to 2.36 kilonewton, and as it is acting away from this joint C, so this means that this is the tension force. Now after this we will consider joint B, right? So let me write that we are considering joint B. So at joint B, since this FBC is the tension force, so it will also be acting away from this joint B as well, right? Since the FBC force is the tension force. So let me write that this is FBC and its magnitude is now known. This is 2.36 kilonewton. Similarly, if we assume that this joint AB is in tension as well, let's say that it is acting, the FAB is applying the force on this joint B in this direction, let's say. So let's say that this is FAB, and let's say that this FBD is applying the force on this joint B in this direction, right? So this is FBD. So now if we apply this is that 4 kilonewton force, right? So Now if we apply the summation of forces along y equals to 0 at joint B, so now as we can see that this FBD is acting in the positive y direction, so I will write FBD, and this 4 kilonewton is acting in the negative y direction, so I will write minus 4. This will be equal to 0. So from this we can say that FBD equals to 4 kilonewton, and since FBD is acting away from this joint B, so this is the tension force. And similarly, if we apply the summation of forces along x equals to 0, so again as we can see that this FAB is acting in the negative x direction, so I will write minus FAB, and this is acting in the positive direction, 2.36. This is equal to 0. So from this we can say that FAB equals to 2.36 kilonewton, and since FAB is acting away from this joint B, so this is also the tension force. Now after this we will consider joint A, right? So if FAB is acting away from this joint B, so it will be acting away from this joint A as well, right? So again FAB is the tension force, so it will be acting away, right? And let's assume that the FAD force is acting towards this joint A. Let's assume that it's compressive force, right? So this is FAD, right? So now if we consider this as a free body diagram at joint A, this is our free body diagram for joint A, right? This is FAB, and FAB magnitude is 2.36 kilonewton, and this is AY, its magnitude is 0.875 kilonewton, right? And this is FAD, and as we know that this ABD and DCB, both of these triangles are similar triangles, right? So if this angle is alpha, then this angle is also alpha. So this means that FAD is also making that same alpha angle, which is 36.87. So now again if we resolve this FAD into its components, so it will have one component which will be acting in this direction, and it will have one component which will be acting in this direction, right? So one component is acting in the negative x direction, and this component is acting in the negative y direction. So now if I apply let me write that at joint A, if we apply the summation of forces along y equals to 0, so as we can see that this is acting in the positive direction, so I will write plus 0.875, and this component is acting in the negative direction, and it is the sine component, so I will write minus FAD sine of alpha, and alpha is 36.87, and this is equal to 0. So from this we can write that FAD sine of 36.87 is equal to 0.875. So FAD is equal to 1.46 kilonewton, and since it is acting towards this joint A, so this is compressive force. And similarly, if we apply the summation of forces along x equals to 0, so as we can see that 2.36 kilonewton force is acting in the positive direction, so this is 2.36. This is acting in the negative direction, so I will write minus 1.196, and this component of FAD is acting in the negative direction, so I will write minus. FAD magnitude is known, so it is 1.46 cos of alpha, which is 36.87, and this is equal to 0. So as we know that in this equation there is no unknown, right? So if our calculation is accurate, right, so this side will be equal to 0, right? So calculator will give us 0, so this will be our final check of our calculation, right? So this value need to be equal to 0, right, since we have done some rounding off, right? So this is 2.36 minus 1.196 minus 1.46 cos of 36.87. So this need to be equal to 0. So this is approximately 0, right? So this is minus 0.0003, right? This is this is minus 0.00399. So this is nearly equal to 0, right? So this is our final check, right? And we have determined the forces in each and every member, right? So this is the solution of this particular problem. I hope you people would have understood this problem. So if these videos help in your learning, so kindly subscribe my channel and like this particular video.